Aha! Question 4. We are moving fast. I hope you've got the first 3 questions right and feeling really good, right? As I said to you, A, this is the way, joy. Take your right hand up. Everybody follow me. J, O, Y. Oh, tilt your body to look a little bit good. I know you guys like to look at a mirror and feel good. Adjust your hair and look at it again. Yeah, so bad. Just touch your hair. Feel nice. And then move on with your math, all right? I know what your raging hormones is doing to you, my dear friends. All right, you're feeling heated up, hot. You feel great. You want to move around, sweat it out, and get going with maths. Now, in this question, this little sweet girl, Jing-Wen, she hit 100 marbles in a school bag. I think during recess time, she maybe wants to have a marble game. Now, what did she do? 20 of them were red, X were green, and the rest were blue. So she had red, green, and blue marbles. How many marbles were green, given the probability of drawing a green marble is 7 out of 20? And then what's the probability that the first marble drawn is green and the second marble is blue? And what's the probability of drawing 2 green and 1 red in 3 draws? And the last one, what is the probability of drawing 2 in the 2 draws that both marbles are the same color? Now let's look at this. You have 100 marbles, all right? 100 marbles, and 20 of them were red. And the probability of getting a green is X, and the rest is blue. And this important information, that the probability of getting a green is 7 out of 20. Probability of getting a green is 7 out of 20. That's the proportion. So you want to find out how many green there are. So the number of green marbles is actually 7/20th of 100 marbles, right? There are 20 units. You divide it by 100, you divide it by 20, and you multiply by 7. So you get a 5 there. 5 times 7 is 35. So the number of green marbles, is 35. Number of green is 35. So you look at Jing-Wen, she has red. Red is 20. Green is 35. And the rest are blue. And how many blues are there? 20 plus 35. You've got a 55. The rest are 45 blue. Now, that answers the number of green. This question, number of green marbles, 35. Now, the next part, what's the probability that the first marble drawn is green and the second is blue? All right, B. The probability of getting a green, the first, and then followed by a blue, a green. What's the probability of getting a green? She's got 35 out of 100. And then followed by a blue. The blue is 45. And now that she's taken 1 out, she's got 99 left. So you've got that, all right? You've got 35 over 100 for green, 45 out of 99 for blue. Now, as I said, we try not to use calculators as much as we can. We divide by 5. This is 7. This is 20. We divide by 5 again. This is 4. This is 9. Divide by 9. 1 upon 11. So the probability that you get is 7 times 1, 7. 4 times 11, 7 over 44, right? The probability that she would get a green followed by a blue. All right, now the next part of the question, what's the probability that you get 2 greens and 1 red? Probability of 2 greens and 1 red in 3 draws. Probability of 2 greens. So she can get a probability of a green, and a red. What else? Probability of a what? A green, red, green. You agree with me? And then what else chances can she get? A probability of a red, green, green. Any more? Because they're both greens. So we don't have, if there's another color, then we're going to play it again. So the order, because you have two greens, is either green or red. Two greens and one red. So you look at it, green, green, red, or green, red, green, or red, green, green. So you add these probabilities up and you would get the answer. So if you look at the first chance, a green, 35 out of 100. The second green will be 34 out of 99. The red, how many reds are there? 20 out of 98. That's the first combination for this. This is one event, an independent event. One, actually I can call it dependent, all right? Because there is no replacement. So one probability followed by another, a green, followed by a green, and then a red. This is called a dependent event because you've taken off one because it depends. Remember, I told you the probability of a dependent event, all right, is probability of if you have a green, then the next one is a probability of you have to get a green over the total number of whatever is left, whatever the total number that you left. And then the next one again, you want to get a red, is again you're going to multiply by the next event that is a red over what is left. So that's a dependent event. Now if you look at that, let's look at this again. This is one trail. So this one event. This is another event. This is one event that can happen, this can happen, or this can happen. So three of them are mutually exclusive as such. You just add up the three probabilities. Now what is the next one going to be? The probability here. This yellow one is for this. This part, the red one, let's look at this. What is this going to be? The probability of a green is a 35 out of 100. A red, there's 20 out of 99. And a green again, you have because you've taken one green out, you've got a 34 out of 98. So this is the second event. And then we look at the next part. Hey, you got a red followed by a green and a green. What's the probability of a red? All right, you look at it, a red, 20 out of 100. A green, a 35 out of 99, because you've taken red out. And then it's 34 out of 98. You can see all the bottoms, 100, 99, 98, 100, 99, 98, 100, 99, 98 are top 35, 34, 20, 35, 34. You can see the same numbers. So what you need to do is you take this answer and you multiply 3 times. Is that clear? So if you look at it, maybe you look at any one of them. I would try to take these two and see what I reduce this to. This is 5 and this is 1. I look at this is 1 and this is 7. And then I stay put and I said, all right, this 2 we can reduce it, but not really necessary. We can plunge it into the calculator. Now, let's look at what this becomes. 7 times 34. All right, what do you get? You get 238. You get 238. And this 99 times 98. 99 times 98. And you get 9702. And then you're going to multiply because there's 3 sets. 1, 2, 3. You're going to multiply it by 3. Is this number divisible by 3? 9 plus 7, what do you get? 16 plus 2, 18. If the sum of digits is divisible by 3, you can divide it by 3. And you can do the caterpillar, I told you. 9702 divided by 3, you get 3. 7 divided by 3 is 2, my dear. Carry the 1, you've got a 3 that is 9. Carry the remainder, you get a 4. So this 2 can be reduced to 3, 2, 3, 4. So what you've got is a 238 over 3, 2, 3, 4, and you can reduce it further, divide it. You can see the last 2 numbers. How do you see if a number is divisible by 2? You look at the last two digits. If the last two digits are divisible by 4, that means the number is divisible by 4. Look at this, 38. Is it divisible by 4? No. How about here, 34? No. But because it's even, you can divide it by 2. You get 1, 1, 9. Here, you get 1, carry the remainder, you get 6. Here, you get 1, 7. So this is your answer. The probability of getting 2 greens and 1 red. Alright? So it's because it's a repeated color that makes it easier. You just have 3 different events to be added. Now the next part of it, let's look at it, and they said, ooh, what's the probability of getting in the 2 drawers the same color? What does it mean? A red red, a green green, or a blue blue? So how do we get that done? The probability of getting a red red, if you don't mind, I answer here. The probability of getting a red red plus the probability of getting a blue blue plus the probability of getting a green green. Alright, that's what it calls for. And you sum them up. These are 3 mutually exclusive events. But this itself is dependent, because you have a replacement, dependent events. So the probability of an R, a red appearing, what is it? You have a 20 out of 100. And then the second red will be 19 out of 99. Add them up. Now here, the probability of a blue. How many blues do we have, my dear? 45. A 45 out of 100. The second blue is a 44 out of 99. The third one, a green. How many greens did we work that out? We had 35 greens. A 35 out of 100 times a 34 out of 99. I'm not going to reduce it. Can you tell me why? Because they have the same LCM when they multiply. So why? Otherwise I'm going to have a headache adding them up. Alright? So look at it arithmetically. Some of us get it right up to there, and then the summing up, we got it wrong. And we said, oh, I made a careless mistake. No! Where was your little brain? You know, they say the size of your brain is the size of your fist. Use it wisely. So we look at that. We said, hey, this sum is 100 times 99, 9900. 20 times 19. 2 times 19, 38. Then you put 0. What is 45 times 44? Well, here, use calculator. 45 times 44, you get 1980. Plus, look at the blue, 35 times 34. 35 times 34, you get 1190. Alright? So, you add them all up. You have 9900. 0 plus 0 plus 0, you get 0. 9 plus 8, 17. 17 plus 8, you get 25. Carry up the 2 for the third number now. 2 plus 1, 3. 3 plus 9, 12. 12 plus 3, 15. Carry 1 over, you get 2. 2 plus 1, 3. So this is what you get. Sometimes you want to get assured, then you counter check with your calculator. 1190 plus 1980 plus 380, and you say, you get 3550. Alright? And then reduce it. Yes, here's the multiple of 5. Divided by 5, you get 71. Here, as I told you, the caterpillar division, 990. You will divide it by 5. Remember the secret that we shared with Kumar. Right, you get a 1. Pass the 4 here. 49, you get a 9. 45. Remainder 4, you get an 8. So this is 198. The probability of getting 2 colors, my dear, is 71 over 198. 71 is a prime number, right? So we've done 4 sums and we've got the 5th sum. And look at it. This is a sum about colored marbles. Probability is always about marbles, balls, beads, dice, cards. What else do you play with? These are things when you look at it. And then we've covered sums on cards and marbles and letters and numbers. I just want to do one with dice. Alright? So just a quick run. You have 100 marbles. You have red, blue and green. You're given the probability of a green. How many green is that? And that's as simple as very easy, basic. You're given a probability. You want to find out how many green. 7 out of 20 are green. So how many marbles are there? 100. You multiply that and you get 720 out of 100. 35 green. Once you've got the green, you get the blue. The rest are blue. So you worked out, you get 45 blue. Look at the way the answers are presented in a systematic way. And then you want to find the number of the probability of getting 2 green and 1 blue. Alright? Green, green, blue. Sorry, green and red. Green and red. So you put green, green, red, green, red, green, red, green, green. Write out the different options. And make sure, or you can use a probability tree. And then from there you fit it in. And I told you the secret, how you do quick multiplication, because the same number is repeated 3 times. You just work that out and multiply it by 3. And also not forgot this part. You want 1 green, the first is green, and the second is blue. Follow that instruction. Pretty simple. And the last part was the probability that both marbles the same color. Red, red, blue, blue, green, green. As I said, we refuse to reduce it because we've got a common base and that would help us make it easier. And if they ask you what's the probability that both the marbles will not be the same color, what do? You take 1 whole minus this. Minus the probability of both being the same. Right? And that will give you the answer for the probability that both marbles are not the same color. They can be 2 other different colors. Alright? So let's go to 5th sum, dice. Alright?